Hey guys, welcome back to my channel, and this is planar graphs discussion part 2. Planar graphs part 2, and today we will discuss the proof why the famous non-planar graphs K33 and K5 are non-planar. Okay, so let us see the K33 graph first. That was the three utilities, three houses and three utilities problem. Okay, this is your K33. I will label the vertices 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3. Okay, okay. So what are the number of vertices? Number of vertices over here. We have 6 vertices. Number of edges. The number of edges is 3 into 3, right? That is 9. And um, let us find, we don't know the number of regions. So what do? Okay, so we know for a graph to be planar, the necessary conditions are number one, Euler's formula. Vertices minus edges plus regions is equals to 2. This condition is true, definitely true. It cannot be false. And one more inequality that we saw in the part 1 of the video. If you have not seen the part 1 of planar graphs, you can find it over in the I tab in the playlist of discrete mathematics. Okay, you can check that video first. So another inequality that is true is, okay, see first that was 3r less than equal to 2e. But note, in a bipartite graph, this is a bipartite graph. We assume that the smallest cycle possible in the graph has 3 edges, right? But you notice in a bipartite graph, you cannot have a cycle of length 3. Why is that? Because you know the property that in a bipartite graph, the edges are across the sets. It is not within the set. So I will change the color over here. So if you start from vertex 1, go to vertex 5, this is length 1, then you move to the vertex 3, this is length 2. Then to get the cycle of length 3, you have to make an edge within the same set, which is not allowed. So you can have cycles minimum of with 4 edges. Okay. So this inequality does not hold true over here. So what should be the inequality? That 4r is less than equal to 2e. You have to be careful over here. Okay, always be careful what graph you are looking. So according to the graph, what is the minimum number of edges in the cycle, that would might change the inequality. Okay, so what we will do, we don't know the number of regions, so we will substitute the value of regions from here in the Euler's formula in this inequality. Okay, I will change to blue again. So what is r from here? R is nothing but 2 minus vertices plus edges, and we will substitute this over here. 4 times 2 plus minus vertices plus edges, yes, uh, is less than equal to 2e, and this we can cancel off. So 2 into, see, edges is 9 minus 6. Okay, 9 minus 6 is 3. And 2 plus 3 is 5, is less than equal to the number of edges, that is 9. Correct. Now it is coming 10 is less than equal to 9. We assume that K33 is planar. But if we assume it to be planar, then the inequalities which is always true for planar, any connected planar graph, that is giving something absurd. 10 cannot be less than 9. So that means we can conclude that our initial assumption that K33 is planar is false. So this would imply I'll write in the next page. So this would imply that our assumption that K33 is planar is wrong, because K33 planar, this is planar. This assumption, it led to absurd. So that means our initial assumption is wrong. So K33 is non-planar. Okay? Alright. Now we will see the next graph, that is K5. K5, that is a complete graph on 5 vertices, is also non-planar. We will also first assume that it is planar and then come to some absurdity that will mean that our initial assumption that K5 is planar is wrong. Okay? Alright. Okay, fine. Alright. How many vertices we have over here? Vertices is 5. How many edges we have? Because it's a complete graph, that would be 5, choose 2. That is nothing but 10. Okay. And what about the regions? We don't know the regions. So again what we will do is, we will substitute the value of r in terms of v and e. Now this graph can have 3 cycles. So our inequality would be 3r less than equal to 2e, and the Euler's formula v minus e plus, okay, we'll write e like this because it's the same variable. So we'll write it like v minus e plus r is equal to 2, because we assumed K5 is planar. So these two should hold true. Okay, but this will result in an absurdity. Okay, so what we do is, from this equation, what we will do, we will find the value of r. If K5 is planar, we will get what the value of r should be. And then we will substitute the value of r in this above inequality, that will lead to the absurdity. Okay, let's do that. So I will remove the above portion and write it over here. Hope that's fine. Then, okay. So we have 5 minus 10, that is minus 5. Minus 5, okay, plus r is 2, or r is 5 plus 2, 7. So r is coming out to be 7. Okay. So, and we plug this 7r's value in this inequality, what we get, 3 into 7 less than equal to 2 into edges 10. So it is coming 21 less than equals to 20, which is absurd, which is not true. That means K5 is also non-planar. K5 is non-planar. Okay. So hope you learned something from new from this video. If you like this video, please share it with your friends, subscribe to my channel, and keep exploring. Happy learning. Bye bye.